This is Algebra 1, Lesson 6A, Rules for Addition. It's going to include examples 6.1 and 6.2. Now that you know how to show algebraic addition on a number line, we're going to learn the rules that allow us to add signed numbers without drawing the number lines. Okay, so keep doing that in your homework when they ask you to draw a number line so you can practice it. And for our first example, we are going to draw all the number lines and just try to figure out the rules so that we don't have to draw the number lines on future problems. Add example 6.1, add +1 and +3. Okay, so the problem would be 1 plus 3. Now we know the answer to that is 4, right? We can do that without drawing it, but let's show that we can do it on a number line. So we always start at the origin, or 0, and then I'm going to go the distance of the first number, +1, so that's 1 in the positive direction. And then I'm going to pick up from that spot and go +3, so 3 more in the positive direction. And that leaves me here at 4. And I can see that the answer is 4. All right, now what if I add -1 and -3, which would look like this, -1 plus -3. I do the same thing. I start at 0, the origin, and I'm going to go this time, though, 1 in the negative direction. And then I'll pick up from that spot and go 3 more in the negative direction. And that leaves me at -4. So this answer is -4. Now, a +1 and a +3 equals a +4. A -1 and a -3 equals a -4. We need to generalize this. What do we notice about this? Well, if both of the numbers that you're adding, so here I'm adding 2 positives. If you're adding 2 positives, that means when you start at 0, you're going in the right direction and then you're going in the right direction some more. You didn't ever go in the left direction, right? So since you are ending up, you're only traveling to the right of 0, you're going to end up on the right of 0, which means you're going to get a positive. So if you have same signs, you get the same sign. So look over here at the one on the right. We started at the origin. We have a negative and a negative. We went to the left, and then we went to the left some more. So, of course, we ended up on the left. So when our signs are the same, whether it's 2 negatives or 2 positives. So here we had a positive plus a positive. Here we had a negative plus a negative. If the signs are the same, you're going to end up with the same sign. So let's see how to generalize that. To add signed numbers that have the same sign, we add the something with 2 words of the numbers and give the result the same sign as the sign of the numbers. Okay, let's go back and think about it and see if we can figure out the term that goes in the blanks. Notice that with the first one that we did, +1 plus +3, we traveled 1 in the right direction and 3 in the right direction. Notice over here on this example, we still traveled 1, but it was in the left direction, and we still traveled 3 in the left direction. Both of them were traveling 1 and 3. The only thing that changed is which direction we went in. So when you're talking about traveling a distance, do you remember we've talked about the distance a number is from 0 on the number line has a special term, and it's 2 words. Do you remember it before I write it? So what we're really doing is when we're adding signed numbers that have the same sign, both positives or both negatives, we're adding their absolute values to get the result, and then giving the final answer the same sign as the numbers. Let's try that mathematically for a second here. Let's go back to this example here. What's the absolute value of +1? +1, just a 1. What's the absolute value of +3? 3. What's the sum of their absolute values? 4. They both were positive, so we make it positive. Let's try that over here. What's the absolute value of negative 1? How far is it from 0? It's 1. How far is negative 3 from 0? So what's its absolute value? 3. We get 4 also, but since these were both negative, that's what we assign to the final answer. That's what this rule means. Let's read it one more time. To add signed numbers that have the same sign, either both negatives or both positives, we will add their absolute value of the numbers and give the result the same sign as the sign of the numbers. So that's our rule. We don't have to draw a number line to be able to figure it out if we know this. And we'll practice it some more when we do the other examples. What happens if you add signed numbers who have different signs? What are you going to do if they have different signs? So think about that for just a second. Instead of going the same direction on the number line, whereas up here, we went to the right and then to the right, and then here we went to the left and then to the left, what would happen if those numbers have different signs? Think about that. Let's do an example that helps us think about that. And then we'll try to generalize it to a rule. Add negative 2 and positive 5. We're going to use a number line just to be able to figure it out. Start at the origin, go back 2 to the left, and then pick up from there and go 5 to the right. 1, 2, 3, 4, 5. And then we stop there. We ended up at positive 3. Let's do positive 2 and negative 5. Start at the origin, go to the right 2, and then pick up from there and go back 5. 1, 2, 3, 4, 5. We end up at negative 3. So let's see if we can think about what happens here. We're not adding their absolute values because we're not going the same direction, right? We had to switch directions. We started at the origin and we went to the left, but then we had to turn around and go back to the right. So you're not going to add those differences. What are you going to do? Or you're not going to add those numbers. What are you going to do with those numbers to figure out where you end up? Well, let's read the rule and see if we can fill in the blanks. To add signed numbers that have opposite signs. So here we had a negative and a positive. Here we had a positive and a negative. To add the signed numbers that have opposite signs, subtract their what of the numbers and give the result the same sign as the original number with the largest. I bet you can figure this out from the last one that we did, a 2 blank answer. Notice that if you took 5 and 2, the absolute values of these numbers, the absolute value of negative 2 is 2, the absolute value of positive 5 is 5. If you take those numbers and subtract them, you get 3. Well, how do you know if it's going to be positive or negative? You take the sign of the number that had the largest absolute value. Notice that 5 is the largest absolute value, and 5 was positive. And if you think about that the one with the larger absolute value, that means we went more in that direction for this one. The 5 is the bigger absolute value. It's bigger than the absolute value of negative 2, which is 2. And I went further to the right than I went to the left. So I'm going to end up on the right, so it should be positive. But if you look at this example over here, absolute value of positive 2 is 2. Absolute value of negative 5 is 5. Let's subtract those. 5 minus 2 is 3. But why is it negative? Well, that's because the absolute value, the largest absolute value is 5, and it was originally negative. So we went more in the negative direction. So our answer is going to be negative 3. To add signed numbers that have opposite signs, subtract the absolute value of the numbers well, I should say values, I guess, of the numbers, and give the result the same sign as the original number with the largest absolute value. Okay, so you're looking at the absolute value. How far did you go in each direction? Consider numbers that have the same absolute value but different signs. For example, -5 and +5. What's their sum? Okay, if you're going to add those two, remember that's what sum means. Sum is the answer to an addition problem. If you add -5 and 5, think about that on the number line. You went to the left 5 from 0, and you turned around and went back to the right 5. You're going to end up right back at 0, aren't you? Do you remember a term for numbers that have the same absolute value, but they have different signs? So like -5 and 5, right? Or -2 and 2, or 7 and -7. Those are opposites. They're called opposites. The sum of opposites, opposite numbers, the sum of opposites is always 0. When you add opposites, you're going to get 0 because you're just going right back to 0, right? And then I put also an AKA here. There's another term for opposites in your book, and it's going to use that term, so it's going to be helpful for you to know what that term is, and it is called the additive inverse. That's just the mathematical name for an opposite. And these are equivalent expressions. You can use them interchangeably. But if they say, what is the additive inverse of 10? They want to know what is the opposite of 10. So they're saying, hey, if you go over to 10 on the number line, it's 10 to the right. What would 10 to the left be? Well, it would be -10. So let's do some examples thinking about our rules up here, that if we add things with same signs, we're going to add their absolute values and they have the same sign. But if we add things with different signs, we're going to subtract their absolute values and take the sign of the one with the largest absolute value. Okay, and I'm going to zoom in like these, and we're going to do them. We're not going to do A, B, C, D. We're going to do A, C, E, G, and then jump over. All right, so for A, I have a +7, and I'm adding a -3. If you think number line, I'm going to the right 7, turning around and going back 3. So I'm not going to add these two. I'm going to subtract them. They have different signs. 7 minus 3 is 4. Then I have to think, okay, is it going to be positive or is it negative? Well, 7's absolute value is 7, and it's larger than the absolute value of -3, which is just 3. So I'm going to take the sign of the one that had the largest absolute value, and that one would be a positive. So this is +4. And again, if you think number line, we went further to the right, the positive direction, than we went to the negative direction. C, -7 plus -3. Both of those are negative. So we're going left 7, left 3. We're not switching directions. So we're going to add them and get 10 and keep the same sign. E, two different signs. We've got a negative, we've got a positive. So we're switching directions. So we're going to need to subtract them, and we get 4. Which one has the largest absolute value? This one's further from 0. So we're going to make it have a negative. G, same signs. Both are negative. So I'm going to the left 4 and then the left 1 more. Since I didn't switch directions, I'm adding these and keeping the same sign. Okay, I'm going to switch over to these. Maybe you could pause the video and you try these, or just the first one maybe on your own. With B, I've got +2 plus +6. Right 2 and then right 6 more. That's going to leave me at 8 and keep the same sign. D, left 2 and then left 8 more. Same sign, so I add them and keep the same sign. F, different signs. So I'm going to the left 2 and then right 8. This is where I subtract them. 8 minus 2 would be 6. And keep the sign of the one that has the largest absolute value, which is 8. It's positive, so the answer is positive. H, positive 2 plus negative 8. These are different signs. So that's where I subtract their absolute values. 8 minus 2 is 6. Which one has the largest absolute value? Well, that would be 8. So it's going to be negative 6.